Hi, this is OrgoChemSimplified, and today we're doing a carbonyl mechanism problem. We have this nitrile group here, and we're asked to figure out how do we get to this amide. Our reagents are acid and water. So whenever you're doing a mechanism problem, just think about how the first step is going to start. So you have this nitrile group, and you have acid and water. We know the first thing that always happens in any reaction is acid-base chemistry. And so we have an acid here, so this nitrile is going to get protonated. Well, what's the most basic atom in this nitrile? It's going to be that nitrogen. So what happens is this nitrogen is going to grab that proton, and we're just going to get a protonated nitrile group. So here's our NH+. Okay, so now that we have this compound, this should remind you a little bit of a carbonyl because we have a carbon here and we have multiple bonds to a more electronegative atom. So based off that, we know that it's going to react exactly like a carbonyl will react. So it's electrophilic. So what we're going to do is we're going to grab our electrophilic or our nucleophilic atom, which is water, and we're going to attack that carbon right there. So we're going to grab water. Water has lone pairs, and it's going to attack that electrophilic carbon. What happens is, when it attacks that electrophilic carbon, it pushes those electrons up to the nitrogen. And so we get two sp2 centers. Okay. So what's going to happen next? Well, you have a positive charge in this oxygen atom. It's going to get deprotonated. What's the most basic thing we have? Probably another water. So water's going to come along. It's going to take away that proton. And so what's the next compound? Next compound is just going to be the deprotonated version of our previous compound. And so now we have this compound, and how are we supposed to think about what's going to happen with it? Well, if you look at this molecule, especially this part where we have all our functional groups going on, we see we have an OH and a double bond right there. That should remind you a little bit of something you've probably seen before. It should remind you of an enol, right? You have an alcohol group and this double bond right here. But instead of being bonded to the carbon, now it's bonded to the nitrogen. But it's going to react in the exact same way. What do we know enols do? We know enols tautomerize. And so that's how we go from this alcohol here to that carbonyl up here. It tautomerizes. So what happens when an enol tautomerizes? Well, we have a lone pair here. Lone pair's electrons come down, and this double bond will go grab another proton. And so what do we get when that occurs? This part of the molecule is the same. You get a double bond O and an H, so that's a positive charge. And now we get an NH2. So now this is beginning to look really similar to the product that we want. What's the only difference? This positive charge. And so how do we get rid of it? We depronate it. So we just grab another water. Water will come and take away that proton. And that's going to give us our product. So as always, whenever you're trying to do a mechanism problem, don't try to knock it out all in one shot. What you do is you look at your starting materials and see how they interact. You know you have an acid, and that's going to be the first step. So just protonate it with the first step. And look at this molecule. And once you've looked at the protonated molecule, try to think about what it reminds you of. And it's going to react in the exact same way as something it reminds you of. So this reminds us of a carbonyl carbon. So it's going to react in the exact same way. And this reminds us of an enol. And so this reacts in the exact same way. And so if we relate what we don't know to what we know, we're able to figure out the mechanistic steps that occur. So hopefully that helped. And if you liked the video, please send it to your friends because I want to help as many people as possible. And so, thanks for watching.